Good morning. I'm going to go over this lecture here, Nebula Lecture, and we'll learn a few of the basics about nebula and a couple of different types. So we have this image here. We've seen images like this of space, and what you're seeing are examples of these large clouds of dust and gas. So nebula are large clouds of dust or of gas and dust. These clouds are formed in a variety of ways. Now the color that you see here is color that's been enhanced. So the images have been enhanced. It wouldn't really look like that. We're bringing out the colors, even though these wavelengths are given off by these clouds of gas. Okay, we come down here. This is an example of a diffuse nebula. Diffuse nebula are the most common. They are formed from the gravitational attraction of nearby gas and dust. So the gas and dust slowly starts to come together, and these are huge. These are huge. These are areas that are the size of our local stellar neighborhood. So, you know, in some of these gas clouds, you'd be able to fit easily 50 stars, 75 stars, 100 stars, big, huge areas of gas. Okay. Diffuse nebula will start to have areas of higher concentration. And that's what we see in this simulation, is we see all the gas and the dust. In some areas, it's becoming more concentrated. All of this right here is more concentrated. These areas will eventually form stars and star clusters. And we can see like this swirl right here, there's a star being formed right there. Right here, this swirl, stars, stars, star, star, star. So this is how solar systems start to form, is this gas swirls and gravity starts to pull it together. Okay, those are the diffuse nebula. Now let's look at a different one. In this image, you see the cloud of gas and dust here, but you also see at the very center a white dwarf star. Planetary nebula form from the death of a normal-sized star. This is what our sun will do. Our sun will do the same thing because it's not a very large star. It's just a medium normal-sized star. The outer layers expand and eventually drift away as a cloud of gas and dust. So our star will not explode into a supernova. It's not big enough. So the outer layers will get bigger, 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 and eventually they'll just pull away from the inner core, which shrinks down into a white dwarf star. Okay, and the third type that we're going to talk about is the supernova remnant. And that's what we see here. Kind of looks like the planetary nebula, maybe a little bit more chaotic. Supernova remnant nebula are the leftover debris from a supernova explosion. So now we have a big star, more massive than our sun, that has exploded into a supernova, and all that material gets thrown out in the explosion. This is where our heavier elements are found. The supernova is so powerful that it's able to create our heaviest atoms, things that we find above iron. These are also smaller than our diffuse nebula. So the planetary nebula and the supernova remnant are smaller, much smaller than our diffuse nebula, which are huge. All right, so with this supernova explosion, I want you to think of one other thing. The force from a supernova explosion will interact with other nearby nebula. And we see this in the image here. We have a supernova explosion, and then close by we have another cloud of gas. Maybe this is a diffuse nebula. That explosion pushes outwards slowly through space, and it can affect this cloud of gas. So the cloud of gas was stable. Now the supernova went off, and it pushes some of the gas together, starting this star formation, starting that gas and dust to clump together in higher concentrations. This interaction can start a star-forming wave. All right, I hope this helps. Thank you very much.